Okay, so now we're going to look at multiplying and dividing with fractions, and then multiplying and dividing with decimals. These are, for right now, going to be both positive. I'll make one negative. That way we can apply our integer rules with it, so that we're keeping that fresh. All right, so the last two sections, multiplying and dividing with fractions, multiplying and dividing with decimals. When multiplying and dividing with fractions, our rule of thumb is to multiply straight across. Straight across. Okay, and once you have done that, then, so that's the first thing, and then once you've done that, you can then reduce, okay, or simplify. You can also reduce diagonally first, meaning you're going back and diagonally, so from a top to a bottom on the other one, or bottom to a top on the on a different one. And I'll talk about it, but I won't necessarily show it because we simply want to just multiply straight across first, and then you can reduce. All right, so let's go ahead and do an example on that. If I have 2/3 times 1/2. This is where I say you can reduce diagonally. 2 and 2 can both be reduced by 2. If I had the 2 here on bottom and the 2 here on top, I could also do it this direction, but it's diagonally. I'm going to go ahead and show just multiplying straight across first. So 2 times 1 is 2, and 3 times 2 is 6. Then the last step is to reduce. And so 2 divided by 2 is 1, and 6 divided by 2 is 3. Okay? You can reduce diagonally first, which is this reduction here, and then multiply straight across. But the simple thing for multiplying fractions is multiplying straight across first, then reduce diagonally, or reduce to get your answer. All right, for dividing fractions, we use a different color. Dividing fractions, we did KFC. So KFC, and I talked about it helps us remember with Kentucky Fried Chicken. All right, and let's go ahead and put on here. This was, well, you have multiplying here, and this is dividing. All right, that way you're not trying to use KFC for multiplying. That is completely wrong. It's only for division. Basically, what we're doing when we're doing KFC is we're making it into a multiplying with fractions so that we can just multiply straight across and then reduce. So the K stands for keep, F stands for flip, and the C stands for change. We're going to keep the first number, flip the second number, and change the operation. Okay? An example for that is if we have 1/2 divided by 3/4, we need to do our KFC. So this looks like 1/2, which is keeping the first fraction. We're going to change the operation to multiplication, and then we're going to flip the second fraction to 4/3. And I said this was called the reciprocal. Okay, our new problem is 1/2 times 4/3. Again, if you like doing the reduction diagonally, here I can reduce the 2 and the 4 by 2. But we're going to go ahead, now that we have our multiplying with fractions, which is this one right here, is we're going to multiply straight across. 1 times 4 is 4. 2 times 3 is 6. And then looking at 4 and 6, I can reduce by 2. And 4 divided by 2 is 2. 6 divided by 2 is 3. And so the outcome is 2/3. Real quick, go back over it. We have 1/2 divided by 3/4. We used our method of KFC. Keep the first fraction, flip the second fraction, which is reciprocal, and we're changing the operation from division to multiplication. Now that we have a multiplying fractions, problem, we can use our multiplying fractions rules, which is multiply straight across. When we get our outcome, we want to make sure that we need to reduce if necessary to get to our answer. Moving on to decimals. Okay, we have our multiplying with decimals. So first thing, let's write this in red. This first spot is going to be multiplying. All right. And the big thing with multiplying with decimals is that it's about the number of decimal places in the problem is how many you need for the answer. Okay? And I'm going to go ahead and put a line here so that when we write our dividing, we have hopefully enough space. I'm hoping we don't run around. So multiplying decimals is the number of decimal places in the problem is how many you need for the answer. Okay? If there's only 2 in our problem, then we need 2 in our answer. If there's 1 in the first number and then 2 in the second number, that would be a total of 3 in our problem. And then you would need 3 in the answer. All right, so we're going to look at least 2 examples, or one. We'll look at one example for that, and then we'll see if we have room for another one. All right, so if we're multiplying 1.5 times 0.13, okay? I didn't write this in here, but the first thing I told y'all in class to do is to multiply your numbers like normal. Just go ahead and do your multiplication first. And then once you have an answer, worry about where the decimal goes. So 3 times 5 is 15. 3 and 1 is 3 plus the 1 is 4. Put a 0 because we've used the 3. We're putting it as a placeholder. 1 times 5 is 5. 1 times 1 is 1. We add these together. We have 5, 9, and 1. And now let's look at how many decimals we have in the problem to put in our answer. This first number has 1 decimal place. This second number has 2 decimal places. So in our answer, we need a total of 3. 1, 2, 3, and then we place our decimal. So our answer is 0.195. All right. I'm going to go ahead and move to dividing decimals real quick because I want to make sure I have enough space for that. I'm going to adjust so that my screen doesn't get in place. I don't want my screen there to get messed up with the space that we have. All right, so dividing decimals. Let's go ahead and put this in a different color. Our rule of thumb is to make the outside number into a whole. So here is dividing with decimals. The key is the outside, oops, don't know why I did that. Outside number needs to be a whole number. And if you have to move, if you have a decimal on the outside, that means you have to move it to make to the right to make it a whole number. So the number of times moved on the outside, and I'm running out of room, do the same to the inside. Should have planned it better. All right, so the outside number needs to be a whole number. The number of times that you move it on the outside, you do the same on the inside. Now again, the outside number is your denominator. The inside number is your numerator. This is like if they were stacked one on top of the other. If you do something to the bottom, you must do it to the top. If you do something to the top, you must do it to the bottom. So the outside number is your denominator. The inside number is your numerator. Let's go ahead and look at an example of that. If we have 0.5 divided by 3.05, okay? Rule of thumb, outside number is not a whole number, so we make it by moving to the right one time, and that makes it a whole number 5. If I did that on the outside, I must do it on the inside and take it straight up into the answer. So now I have 5 divided into 30.5. Okay? Now you just do your division like normal. 5 does not go into 3, but it does go into 30 6 times. Remainder of 0, so we bring down our 5. 5 goes into 5 one whole time. Okay? At this point, you can take your foldable and close it back up. And then for each of the black lines right here, and actually, you know what? Go ahead and put another line here. So for each one of the lines, let's put that black line there. Go ahead and cut to the seam. So you want to cut each one of these black lines to the seam. And so if I want to see what that would look like, we're going to cut here and here. Okay, I'm not going to go all the way down because I want to tell you how this will help with studying purposes. So go ahead and you can continue. But when you're studying for our post tests in our class on Fridays, you can see operations with rational numbers. For your adding rules, you can simply try to remember them and then look to see if you were correct. Then you can say, okay, operations with multiplying integers. I believe it was a tic-tac-toe. Yes, all right, and then look at your example problems to make sure you remember how to do those individual problems.